So a basic targeting and camera lock-on system can be good, but it's also going to be a little bit limiting. I made a video a while ago about how to set up a very basic system, but that one effectively just rotated your camera every tick to face toward the thing that you're trying to focus on, which is limiting and maybe not entirely very smooth. So today let's talk about the implementation that goes a little bit deeper into some flexibility that I'm actually using in my own game as well, which is heavily inspired by the way Kingdom Hearts 2 does its locking. So I'm here in a previous project of mine that has a basic targeting system that's just to serve our locking so that we have something to lock onto. It's not entirely necessary, but if you download the project file, it's also going to have the targeting system, which there's an entire video on that as well on the channel. But let's get into this. So what we want to do is we want to go into our little third-person character here. And first and foremost, what we're going to do is we're going to be adding a couple of variables. Number one is going to be an actor that we're trying to lock onto, so our like focused enemy or whatever you want to call it, which will be of type. You can make this of type like enemy if you have a specific like enemy class in your game, of course, and you're only going to be able to lock on to enemies or only to interactable actors or whatever. I'm going to make this just of type any actor, at least for the time being. And then I'm also going to make a locked on variable. And this is just going to keep track of whether or not we are locked on at this very moment. For troubleshooting, I'm going to just add a cdebug key. This can be any debug key, doesn't really matter what. And that's going to set our lock on to lock on not boolean. So this will effectively just toggle it on and off. Of course, you would want to point this to an actual input action with the enhanced input system if you're doing this in your own game. So now what we need to do is we want to see if our enemy that we're trying to focus on is at this moment on the screen or not. Because we only want to adjust the camera if the enemy that we're trying to focus on has gone off screen, because that will give us the flexibility to still look around and move the camera while we're like in mid combat or whatever, but make sure that the enemy isn't going to go off screen or anything like that. So let's make a quick function for that. And I call that is enemy near screen border. And that's going to take an input of the trigger distance. So, which is going to be a float. This will be the distance in a percentage from the border of the screen. We're going to only go in the horizontal direction for this video. You could technically also check the vertical direction, but largely speaking, that's a lot less relevant, because if it is going off the top or the bottom of the screen, it's also going to be very likely to quickly go off the sides of your screen. So this is a 0 to 1 value on how far away from the edge of the screen in either direction it can be. So if we set that to something like 30%, which would be 0.3, it would trigger whenever an enemy enters the area on the left 30% of your screen or the right 30% of your screen, or if it is just off screen in the left or right direction altogether. I'm going to set this default value to like 20% roughly. I have it in 10% in my own game. You can play around with this a little bit. Immediately, we need to check whether or not our focused enemy is valid or not. So we can just drag it in, a reference to it, and then we can convert it to a validated get, because this will check whether or not it is valid. If it is valid, we're going to move on. If it is not valid, we just immediately return. And that gets us to our return values. So this is just going to return a bool. And that bool will call something like is near border, which will be a bool. Obviously, if we don't have a valid focus enemy, it's not going to be near the border because our focus enemy is not going to be valid at all. But if it is valid, we want to get the actor location from it. We need to convert that from world space, because this is just where it is in the world, to screen space. Where is it on the screen for the player that's playing the game? Well, for that, we have projects world to screen. This takes in a player, which is a player controller, because that is a thing that's responsible for the viewport and dealing with the actual like screen that we have. So we can just get the player controller. Of course, if you're doing something with local multiplayer, the player index then might start mattering. For the most part, this should be good enough. World position will just be our get actor position. I'm going to keep player viewport relative to off. This only really matters if you're doing like split screen stuff, or if you have like a widget within your screen that you're playing off of, which for the most part, that's not going to be the case. So now we have the screen position of our character, which is exactly what we want to know, because we want to know if it is on the trigger zones of our screen. In order to figure that out though, we need to know what the values are for our screen. So we want to get the viewport size, and that just gets us a vector 2 with the x and a y value for how big our viewport is. So even if this is not a traditional like 16:9 viewport, if you're playing this on like a 4:3 monitor or whatever, something weird, this in theory still should work, because we're getting the viewport size, which just gets how big the viewport is at the time of requesting this. So now let's split this, because again, we're only going to really worry about the x value. Split both of these. The y value, you can do the same thing that we're going to do here with the y value. It's not that relevant, because it then also needs to start rotating in like other directions for like your camera direction, and that's going to mess you up, and you don't really want to do that. So just do the x value, and that's probably going to be good enough for what you need. And now we figure out the threshold. So what we do is we get the viewport size, x, and we multiply that with our trigger distance, which is technically just a local variable here. So we can just get trigger distance. And that is the distance from the screen border that this thing is going to start triggering. But that will only trigger for the left side of the screen, where it goes from 0 to that value. So what we need to do is we need to find a bool that is whether or not it is near the X border on the left or the right side. So we check the enemy screen position being less than this value, and then we add an OR boolean, because we're also going to check whether or not it is greater than the total viewport size minus this threshold value. Because if we take the total screen size, we have this line over here at the right side, and then we subtract our little buffer from it in terms of like width, we also now get it triggered when we have the enemy over in this direction. And since it's an OR, whether it happens on the left side or the right side, it's going to be returning a true. So with all that, let's add another return node, and that returns. So this is the setup for checking whether or not we want to be rotating at all. Because when we reach this, we want to rotate the camera around for it to reach a position where at some point this becomes false again. So the way that I do that is going back into my event graph. We have our event tick here. I'm going to personally section this off as a sequence. Everything that we did before for our targeting system is going to happen first. And then after we do that, I'm going to just effectively check if the enemy is near the screen border with. Again, we're going to set the trigger distance by default to 0.2. You might want to play around with that a little bit. This is just going to check first, is our focus enemy valid, which at this point I don't think we're setting that anywhere. So we'll do that in a moment. And if it is valid, it's going to calculate whether or not it is near a border of the screen. So if it is near a border of the screen, what we want to do is we're going to make a new variable here, and this is going to be called lockCam movement. And if this is true, we'll set lockCam movement to being true as well. Then going back to the sequence node here, we're going to add a third one, which we're going to immediately do a branch check on lockCam movement being true. Because if our lockCam movement is true, that is where we're going to be moving our camera around to face toward the place that we want to face toward. Then do a check whether or not we've moved it enough, and then if we have moved it enough, we're going to set it to false again, so that it's going to stop moving. So here, we're once again getting our focus enemy. I'm going to make this a validated get, just to make sure that it is valid. If somehow this is true, but this is invalid, we just want to set this to being false, just in case. Then we get the actor location of this as well. And then we get the actor location of our player character itself. And then we'll find the look at rotation. And now it kind of depends on how you have your project set up. For my project, I am using the camera boom with the Bourne's control rotation. For a lot of your projects, that's also going to be the case. So I'm going to set the control rotation for my controller. If you have this set to false for whatever reason, what you might need to do is you might need to get your camera boom and instead set world rotation. But that only works if you are not using the control rotation, which you very likely will be. So instead we will get the player controller and from that set the control rotation. And here we will just make a rotator real quick. What we'll do is we'll get the current control rotation and we'll feed that into the X and the Y. So we'll get the control rotation, split structure pin, X and Y we're not going to change at all. We only want to change the yaw or the Z rotation. And for that, we're going to interp that. So we will get a F interp. Now you get F interp 2, which is a little bit smoother, or F interp to constant, which is a linear movement. So this will have a little bit of smoothing in and out. This will just be linear. I'm going to go with the linear one because it's a little bit more responsive. And we're not actually going to get to the end of this animation or this like movement anyway. So the delta time will be hooked up to our event tick delta time. The interp speed is how quickly you want this to move. So this is a little bit of trial and error. Let's say 15. It's probably going to need to be a little bit faster. And then the current will be our current yaw rotation from our get control rotation. And then our target will be the look at rotation. So we'll try moving toward looking directly at it, but at some point we're going to stop doing that. And that's how we set our control rotation. And do make sure that you're not an idiot like me who connected up this lock camera movement to set control rotation. What we want to do is we want to set camera control rotation here when this validated get is valid. So hook that up to there. Now, after we do that every frame, what we want to do is we want to check if it should keep doing that. And the way that we're going to do that is just by running is enemy near screen border again. So we have that function, we can just drag that in. And instead of our trigger distance being at 20% in this case, we want to check whether or not it's relatively close to the center of the screen. Maybe not exactly at the center of the screen, but something like 45%, maybe just 40%. Just something that makes it rotate toward being roughly near the center of your screen, at least in the horizontal direction. And if it is, what we'll do is we'll drag in a lock cam movement and we'll set it to false. So here we'll have another, branch, but instead of on the true, we're going to go on the false, because when the enemy is no longer within that trigger region, it means that it's outside of the trigger region, which means that it's in the center of our screen. So we're going to stop having our camera move. And then when it goes outside of it again, this will start running again. And then when it's figured it out again, etc., etc., etc. So now the only thing that we need to do is we need to change this code to where we actually can like set our focused enemy, because we have this targeting system. I'm going to go over this really quickly. Again, the targeting system is part of a different tutorial. If you haven't seen that, this is not going to make a lot of sense, which is why I'm skipping over it a little bit here. But what I want to do is, if I am locked on, I don't want the targeting system to do anything. So effectively, our targeting system is just going to set our focused enemy. We have this weight closest enemy every single frame. But whenever I have this as locked on, it's not going to update it anymore. So it's effectively always doing this stuff until it is not. And in this little branch here, after the second bit of our sequence, when we're checking if we are off screen, we also want to build in a branch to see whether or not we are locking on or not. So we can just use the lock on again. And we only want to do this if our lock on is true, because if our lock on is false, we don't want to like be doing any of this stuff. So now we can see I can go up to enemy number 2 and I can set my lock on to true, and I can move my camera around as much as I like, and it's not going to complain until it goes kind of like off screen, at which point it will try to move toward it. Sometimes it decides it needs to go all the way around. If you run into that issue, what you're going to need to do is you're going to need to replace some of this stuff. And instead of interpolating between the float values for only the Z, what we're going to do is we're going to R interp instead. So we're going to interpret between two rotators, and the rotators will interpret between will be our like target rotator, and then our current rotator, which is just our get control rotator, where we will recombine the structure pin, and that will be then our current. So that'll be a little bit more intelligent with the way that it rotates usually. So if you find yourself running into the issue where it like does a almost full 360-degree rotation, doing that should fix that for you. So you can see that now if I make it go off like one side of the screen, it actually like rotates to whatever is the smallest rotation to get to our desired rotation, which is just a little better. Again, it doesn't do this for the up and down directions, but realistically, like, it might not really need to. It's fairly easy to add in if you really want that. I personally find that to be a little like too restrictive again. You would maybe do this as two separate checks. If he is off the Y axis of your screen, it'll do the Y rotation. If it is off the X axis, it'll do the X rotation, so that it can do this independent. That's entirely for you to play around with, but it should be relatively easy to implement. So this is a little bit more of a smoother and a little bit more forgiving lock-on system for your games, and it's the exact implementation that I am personally using, and I spent like 20 minutes looking onto a barrel in Kingdom Hearts 2 to reverse engineer how they do it. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas, and my Cave Student tier supporters, Oiku.